Hello guys, welcome to Bits and Bytes. Previously we discussed about the basics of data science and its applications. In this session, we will learn some basic modules of Python language. We will start with NumPy in this session, and after this, we will learn the basics about Pandas and Matplotlib. So let's begin our journey with our first module, NumPy. What is NumPy? NumPy is a Python library used for working with arrays. It also has functions for working in the domain of linear algebra, Fourier transform and metrics. NumPy stands for numerical Python. We will learn about NumPy arrays, aggregate functions, comparison, mask, and Boolean logic, fancy indexing, sorting arrays and structured data. As you can see, at first we imported NumPy in our notebook. Now, let's create some NumPy arrays randomly. We set the random seeds as 42. If you want, you can change the seed too. The first array has a shape of 6. Since it is one-dimensional array, therefore it has only length 6. The second array has a shape of 3 and 4. And the third array has a shape of 4, 3, and 2. If you want, you can change the shape. Now let's print the arrays. Here toList function is used to print the array as list. You can run it without using toList. Now, let's make a function that will print some array properties. The print array property function takes an array as input and prints its number of dimensions, shape, size, data type, size of each array elements in bytes, and total size of the array in bytes. Let's print all these properties for array x1. You can print for any array you want. Now, let's have a look in array indexing. Array indexing in NumPy is almost similar as list indexing using Python. If you are familiar with lists in Python, this section won't take much of your time. These print statements are very simple. You can change the values to get different outputs. Now, let's move forward to aggregate functions. To get the statistical summary of a data, the aggregation functions like mean, median, mode plays an important role. Some of these functions are demonstrated below. These are just simple functions. The print statements are self-explanatory. Our next topic is comparison, mask, and Boolean logic. A masked array is the combination of a standard NumPy array and a mask. A mask is either no mask, indicating that no value of the associated array is invalid, or an array of booleans that determines for each element of the associated array whether the value is valid or not. Here you can see that some conditions are provided for the array x, and depending on its values it yields true or false for each element in the array. The first line prints true if the element at position I is less than 4 or greater than 8, and false otherwise. Second line demonstrates or operation, and the third one shows not operation. The other lines are self-explanatory. Now we have defined two Boolean arrays to perform OR, AND, and XOR operation. And here is the output. As of now, we saw how to access portions of arrays using simple indices. Now, we'll look at another style of array indexing, known as fancy indexing. So what is fancy indexing? Fancy indexing is like the simple indexing we've already seen, but we pass arrays of indices in place of single scalars. This allows us to very quickly access and modify complicated subsets of an array's values. Few examples can be seen below. You can also play with your own arrays. NumPy also provides sorting functions. We can sort the elements in two ways. The first is using np.sort, and the second one is calling arrayname.sort. Both perform the same task. Just their syntax is different. To demonstrate multidimensional array sorting, we randomly generated a two-dimensional array of 4 columns and 6 rows. For multi-dimensional array, NumPy allows to sort them using their axis. In this case we can change axis equal to 0 or axis equal to 1. And based on the axis value, it will sort the matrix row or column wise. Feel free to change it and run it. Now we've come to our last topic of today, structured and record arrays in NumPy. While often our data can be well represented by a homogeneous array of values, sometimes this is not the case. This code cells demonstrates the use of NumPy's structured arrays and record arrays, which provide efficient storage for compound, heterogeneous data. While the patterns shown here are useful for simple operations, scenarios like this often lend themselves to the use of Pandas data frames. We will see Pandas in the next part. Here, as you can see, we defined 3 arrays: name, age, and weight. After that we define the shape of the data frame and the data type of each column. Then, we assign the columns to the data frame. The complete structured data can be seen below. We can also perform some operations here. Here you can see that we printed the name of the people, whose age is less than 30. You can do other operations too. Now let's move forward to record arrays. NumPy provides the rec array class, which is almost identical to the structured arrays just described, but with one additional feature: fields can be accessed as attributes rather than as dictionary keys. The print statements explains this. Here we can access each attribute using a dot. The downside is that for record arrays, there is some extra overhead involved in accessing the fields, even when using the same syntax. We can see this here. This concludes our today's session. Hope you found that interesting. Please don't forget to like this video and subscribe to this channel. Thank you.